Let's try number 11. Okay, that's good. So you originally just wrote down that I was 2.2, but we always want to put a sign in front of everything. So it's good to put this sign in. And it's good that you put the sign in front of the magnification too. That's a really good habit to keep putting in all these signs.
Going to want to use well the radius of curvature I got was 1.256 or centimeters, and then he's going to want or he or she is going to want to use a convex mirror. Is that what you came up with?
Yeah, good. That's not easy. Good. What's a small mirror? Okay, that was very good. The only suggestions I have are just technical things that will help you to make fewer mistakes. It would have been good to start by writing down the question. It's always good to write down the question. There's a couple places where you didn't put in some of the signs. Most of the time you did. It would be good to put in this sign over here, and this sign over here, and this sign over here. This is just a magnitude. It's good to put in the dots here, because this just gives us the magnitudes. All right, but those are all technicalities. You didn't actually make any mistakes. I got a slightly different answer from you because I was rounding off differently. I got 1.258. I think you got 1.256. Anyway, we're obviously both in the same ballpark there, so that looks good. How do you know it should be convex?
Because it produces a virtual image.
And how does that help us to know it should be convex?
That the convex mirror would provide diverging. The convex mirror would provide diverging lines which would produce a virtual image behind the mirror because you're doing their tracebacks.
Okay, all right. I'm not sure if you got the right mental picture in your mind or not. But you might be thinking the right thing. Here's a slightly more reliable way to work that out. First of all, just when we looked at this here, looking at our points here, we know it's supposed to be upright. What does this 4.5 tell us?
That it's magnified 4.5 times the
So we need something upright, magnified, and virtual. Where does that put us in our chart?
At diverging. Or excuse me, upright, magnified, and virtual is in converging here.
That puts us here. And we know the object must be within the focal point.
Yeah.
So that would confirm your idea that this should be a converging convex mirror. But notice that, I just want to make sure you're clear, converging mirror and convex mirrors don't always make virtual images. A lot of the time they make real, so you have to be a little bit careful about that. Maybe another way to confirm that, though, is what does this tell us?
That tells us
The fact that this is positive.
Yeah, it tells us that it's a converging.
And that means convex, and that confirms your first instinct. So there's a bunch of things that confirm that this is converging, which means a convex. Was this a lens or a mirror?
Mirror.
So we know this should be converging. So draw it, please. Draw what the mirror should look like. Draw what a converging mirror looks like. Okay, now you drew it like this. But the rays would bounce off of that mirror like this.
Excuse me, okay.
This would actually be diverging.
I'm sorry, I got it backwards.
There we go. A converging mirror actually looks like this, because that's what would make the light rays converge towards each other. And is this convex or concave?
It's concave.
All right, so I think maybe that last part of the answer was incorrect. That would be a shame to have done such great work and then lose it at the last step there. So it looks like that's just one thing you want to drill on, the differences, relationships between converging and diverging and convex and concave. The one thing that you didn't do in this problem is you never actually drew a picture. You just went straight into the math. On the test, it would be best to draw the picture, and that might help you to see what the shape of the lens of the mirror was over here. All right, so I made that same mistake. At first I thought you had the right answer here, but a converging mirror is concave. The reason why it's easy to get confused about that is a converging lens is convex, but a converging mirror is concave. We have that table in the handout to help see the difference between them. So this should be a converging concave mirror. You got the right number here for the radius of curvature. Okay, but otherwise all your math came out here very well. You saw that you had to use both the magnification and the lens mirror equation. A lot of people forget about the magnification equation, and you didn't get messed up with the signs. A lot of people would get messed up with the signs here, so that's some good progress.